Alright, for the third lesson of chapter 20, we're taking our scatter plot graph one step further, and we're going to be creating what we call the line of best fit, also known as the linear regression line, the least squares regression line, the line of y on x. You're going to see all these different phrases throughout the book, and that tends to throw people a little bit because why would you need so many different phrases for one thing? But that's just the way they do it. So just understand that these all mean the same thing. So as you look at the scatter plot that I have drawn here, the regression line is simply the linear trend that is taking place through the middle of all of those data points. So first things first, this only occurs if the data is linear. But if it is linear, then we can go ahead and come up with the regression line, which is the green line that you're seeing right here. So that's a regression line. So first things first, there's going to be 3 steps to this. The first one is to create the scatter plot with the data that we're given. So if you take a look at the information given here, I created a scatter plot, which is what we did in our very first lesson of this chapter. So we got the scatter plot going on there. So that's all the blue stuff that you see is step 1. So I plotted the data points that we have, and we can see that that's linear. So that means we can go ahead and move forward with the rest of this problem. So now that we've plotted the data within our scatter plot, we go on to the second step, and this is going to be how you get the equation of the regression line. And this is a line like any other. The equation of the line is just like a y equals mx plus b equation of a line. And so that's all we're doing here in step 2, is just getting the equation of that line. Your book is going to show several different ways on how to come up with the equation of that line. There's multiple methods for doing this. We're going to stick with the easiest way of doing it, which is to get it on your calculator. So these are the steps that I'm going to take you through right now on how to use your calculator to get the equation of that line. And notice when all is said and done, it's just the basic equation of a line, like y equals mx plus b equation. So if you want to follow along, grab your calculator, and we're going to go into our statistics area, and we're going to enter the data from up above as list 1 and list 2 in our calculator, just like we've done in some of the earlier lessons. So let me pull that up for you here on my calculator, just to remind you how to do that. But if you go to Stat and then Edit, right here you have your list, and I've already put the list of data in there for list 1 and list 2. And again, as always, you always do the first row, the X row, as list 1, and the second row is always going to be list 2. So that's what we have in there. From there, and this is what the following steps will tell you on here, and I'll go back to those, but notice the second step says go to Stat, go to Calc, and we're going to be looking at option 4, which is the AX plus B equation. So they don't use MX plus B, they say AX plus B, but it doesn't really matter. So if I go there, so I'm going to go to Stat, go over to Calc, and go down to option 4, which is AX plus B, or linear regression. So if I hit enter on that, and as always, you put your X's as list 1, you put your Y's as list 2. Your frequency list should be empty. Make sure there's nothing showing there, otherwise that will change your information. So just hit enter all the way down, and you'll notice that we're in the same place from the last lesson where we got the R value. So we're on the same screen. There's the R value. We're looking up top here for the values for the regression line. So notice they kind of give you the blueprint, AX plus B, and then they tell you what number to sub in for A and what number to sub in for B. And of course, we're going to do those to 3 sig figs as always. So 3.61 is going to sub in for A. 1.73 would sub in for B. And we have our equation. And so that's what you're seeing right here within the notes. So I sub this guy in for A, sub that in for B. Always use 3 sig figs for those, unless the directions say otherwise. But that's it. So really simple. We pull that right off the calculator from that same location where we got the R value. So those are on the same screen for you. So the last thing we can do now with this is to graph it. So now that we have the equation of the line, we're going to graph it within our scatter plot that we have. To graph a line, we need 2 sure points to plot, and then we can just simply draw the line through those 2 points, and those are the red points that you're seeing up here on the graph. So for the last part here, I'm going to show you how to get those 2 red points within the graph. so that you can make an accurate line. So this is important. These are how you get graded on this. So really important that you follow these steps when graphing the equation of the line. So the first thing we're going to do is we're going to find what they call point M. They call it point M because it's the mean point on the graph. So notice this point is going to consist of the mean x value, so that's the average of your x's, and the mean y value, so this is the average of your y's. And so we're looking for the mean point to plot within that graph. That's one point that we know for sure that our line would have to go through. And so to get that, and I put the steps right here for you, but this is what we're going to do in order to get the mean point. So we're going to go back into stat, we're going to go to calc. We're going into what they call two variable statistics. Obviously we have two different variables here for x and y. So thankfully we already have the data inserted in list 1 and list 2 within our calculator. So that's already in there for you. So you can just go to stat, go to calc, and we're going to go to the two variable statistics right there. So hit enter on that, and of course we've identified where list 1 and list 2 are, no frequency list. And so right there, so you'll notice right at the top they give us the average of our x's, 3.5. And right about here they give us the average y value, which is about 14.4. So as always, we're going to use 3 sig figs for this also. So that's where we're getting those guys. And so we're going to create an ordered pair out of those mean points. And so that's where you're going to get point M right there on your graph. You always want to identify what that is the way I did here. When you plot it on your graph, label it point M. That's what you're going to be asked to do on your test. So it's really important that you get in the habit of doing that within all your homework as well. So label it point M, nice and clear that we found the correct point for that. And then always, again, identify what those values are within the problem for all your homework problems and test questions. So that is one point for sure that we know our graph passes through. The other point is the y-intercept. Remember, this is like y equals mx plus b. The b is our y-intercept of the graph. So right here at 1.73 is going to be the y-intercept. So I'm going to ballpark that as best as I can. That's about 1.73-ish on the graph. So that's my y-intercept. So those are 2 points that I know my graph will pass through. Really important in order to get full credit for this on a test. Your graph must pass through those 2 points. So make sure that you do that. Even sometimes people will lose points because they'll draw the line and they'll stop right about here. Right? You got to make sure it does pass through the proper y-intercept. And so make sure that's well shown within your graph. That's a grading point right there. So those are the 2 points that we got to come up with in order to get an accurate graph.